All right, Series 1, Episode 15. Let's see if we can knock the whole lot out in one go. It says to consider two numbers whose sum is 60. So that means if you add them together, you're going to be 60. I could write that, say, as x plus y equals 60. It's just two numbers equal 60. Right, part A on here says that if the smaller number is x, write an expression for the other number. All right, so if we have x, the other number here, y, I could simply write take x away from both sides. The second number is simply going to be 60 subtract x. So our two numbers are therefore x and 60 take away x. Think about it. If you add those two expressions together, you'll get 60. It works. Those x's will cancel. All right, B, write an expression for the product of these two numbers. Product means multiplication. So the product of those two, x times 60 take x. Perhaps I could expand that out if I wanted to. Usually a bit easier if we're going to differentiate it, which we tend to do a bit of here. We'd get 60x take away x squared. All right, so is that it for B? C. Let the product be p. What is the function p in terms of x? We're almost there. P equals 60x take x squared. We've already done it. We just called it product. D. Find the value of x that maximises the value of p. Again, we've seen that special word, maximise. That means first derivative is 0. So what we're going to do here is we're going to find the first derivative, which will be dp dx, and set to 0, because in doing so, we will find any stationary points. Right, so dp dx is going to be 60 take away 2x, because we just lose the x, 2 comes out the front. All right, we set that to 0, and we solve it. I add 2x to both sides, I get 2x equals 60. Divide both sides by 2, x equals 30. So what did it say? Find the value of x that maximises the value of p. Should we check it's actually maximising? Check it's maximising. Again, easiest way there is probably just to do the second derivative. So I'll do a d2p over dx squared. If I derive that, I lose the constant. I'm going to be left with merely negative 2. Which means the only critical point there must be a maximum. Yay. All right, so I just confirmed that it's a maximum. That's it. We found the value of x there. You could probably put that in a sentence. And E asked for what is the maximum value of the product of the two numbers whose sum is 60. Well, if x is 30, I could easily work out the second number as well. So the second number y is 60 take away x. X was 30. The second number is also 30. So the two numbers are 30. The product then, back here, so the product, well, I could just do it as xy, which is going to be 30 times 30, which is 900. So therefore we can say, answer it properly, we'd say that the maximum product of 900 is when both numbers are 30. If we think about that a while, it's obscurely linked to the rectangle to a square situation in the last question.